All right, in this section, we're going to talk about the graphs of equations. And I know we know a lot of things about the graphs of equations, but again, this is just some reminders for us. So if you want to have some fun, feel free to pause the video now, and you can answer the question on the screen. Which of the points that are listed, and I know there's quite a few of them, are on the graph of the function y equals the absolute value of x minus 3? Now, if you want to save yourself some time, I'll go ahead and do it all for you. Kind of thinking about our equation a little bit. The absolute value, remember, is the function that's going to make everything positive. It's that distance from zero, and distance is always positive. So if we think about our x values, that first number listed in our ordered pairs, and we made them all positive, I want all the numbers that are 3 less than, right? Minus 3, so 3 less than my x value when it's made positive. So I could kind of go through my list and say, well, 1 is already positive. 3 less than that would be negative 2. That's a good point. 7 is positive, but again, 3 less than that would have been positive 4, so that's not a good point. I could kind of go through my coordinates and figure that out. I could also just take all the x values, plug them in, and calculate them all out, but it's kind of doing the same idea. So in that case, we could go ahead and do that. We'd get a whole bunch of good points, and if we went and plotted them, you may remember that an absolute value, because it's making things positive, all the x values pair up with positive x values, such as when you plug in 5, you get back 5. But when you plug in negative 5, all the negative x values also pair up with positive values. So you actually end up getting a V shape going from the origin, sort of going up and out. But now remember, we need to take that V shape and I'm going to subtract 3. So all of those x values, 5 became 5 minus 3, right? It's going to be over here at 2. 2 became 2, but again, dropped by 3. It's going to go down here. And essentially, we're going to end up with that graph. Again, one great way to plot things, just plug in x values, find y values, find a bunch of ordered pairs, and then you can plot them and connect the dots. Don't forget the arrows. Technically, our graph infinitely goes onwards. Now, a couple of things we should be able to do with graphs. Some of the most important points and really easiest points to plot, kind of giving us an idea of where many lines go, are x-intercepts and y-intercepts, because they make life very simple. To be an x-intercept, we want all the points that are on the x-axis. And the one thing that the x-axis has in common is that we haven't traveled up and down. We can travel left and right, but we haven't vertically moved anywhere, which means that the y-coordinate is always 0. The same thing goes for y-intercepts. If we want to be on the y-axis, traveling vertically, then we haven't traveled horizontally. That means that the x-axis, or the x-coordinate, I should say, is always 0. Now, usually with a function or with an equation, if you solved for y, such as the two equations we have, those y-intercepts are usually the easiest things to find. Because if we simply say y equals 0 squared minus 9, right? If x is 0, x-coordinate is always 0 for a y-intercept. Well, then 0 squared is 0 minus 9, and y ends up equal to negative 9. And very simply, we found the coordinate when x is 0, y is negative 9. That same idea works even when we have more terms, such as that quadratic equation we have at the bottom, y equals x squared minus 7x plus 8. Well, again, if y equals 0 squared minus 7 times 0 plus 8, well, 0 squared is 0, 7 times 0 is 0, 0 minus 0 plus 8 is really just 8. And again, we end up with that coordinate when x is 0, y is 8. We found our y-intercept. Don't forget my parenthesis up top here. We found that y-intercept. Now, the x-intercept can be a little bit more tricky because, again, if we plug in 0 for y, 0 equals x squared minus 9. Well, that's going to take some work to solve. Now, not necessarily tricky. If I add 9 to the other side, and then we take a square root on both sides, right? We got to cancel off that squared. So square root both sides. Now you got to be a little bit careful. Remember, when you square root both sides, we got to say plus or minus, because both positive 3 squared would have been 9 and negative 3 squared would have been 9. And we just figured out that there are two x-intercepts. Y is only 0 if x could be 3 or negative 3. Go ahead and try the one on the bottom here as well. It's going to be a little bit more difficult because we've got a few more terms going on. But again, there are lots of ways to solve quadratic equations. I'm thinking this one looks like a good opportunity to maybe factor. X times x, again, would have been x squared. And if we want to multiply to 8 but add to negative 7, multiplies to 8 but adds to negative 7. Well, maybe this wasn't such a great opportunity to factor. I'm thinking 1 times 8 is 8, but again, to add to negative 7, we would have needed a negative number. I'm thinking that's maybe not such a grand idea. 2s and 4s aren't really going to work. Let's take a little different approach. Maybe this is a great chance to practice our quadratic function, our quadratic formula here. We've got x equals, again, we've got a, b, and c, 1, negative 7, and 8, negative b, so positive 7, plus or minus the square root of b squared minus 4 times a, again being 1, times c, all over 2 times a, so just 2. And again, we may as well take advantage of our calculator a little bit here. I'm going to say 49 minus 4 times 8. Again, times 1, but that's not really going to do anything. And basically we end up with 7 plus or minus the square root of 17. Now we can always find that decimal, and don't forget all over 2 there. But if we wanted to stay exact, basically our x-intercepts then are going to end up being 7 plus the square root of 17 all over 2, comma 0. And as long as we're at it, 7 minus. So I'm just going to leave that as plus or minus. We still got 2 of them. And again, you could always find the decimal if we needed to. I hope that helps you remember just a couple things that we can do with graphs. If you have any questions, make sure you talk to your teacher. Otherwise, have a great day.